Hello. In this example, we want to simplify each radical exactly or state that it cannot be simplified. Let's start with e. E is the square root of negative 36. Okay, so here's the thing. We notice that there's a negative underneath here. And anytime you get a negative underneath the radical, you're going to get an I somewhere. And here's a little rule that we can use. The square root of negative a is the same thing as thinking of it as the square root of negative 1 times a. But that's the same thing as square root of negative 1 times the square root of a. But remember what the square root of negative 1 is. The square root of negative 1 is I. So this is actually going to give us I square root of a. So as a result, if you have the square root of a negative, that's equal to I times the square root of that positive value. Why does that help us? Well, if you think about this, it actually helps us quite a bit because there's a negative underneath the radical here. So bring it on the outside as an I, and then just simplify what we get. There, square root of 36 is 6. So this is technically I times 6, but think of I kind of like a variable. You never put the coefficient on the right-hand side of the variable, so let's put this on the left-hand side. And that's going to give us 6i. Excellent. Let's look at f. Square root of negative 18. Again, we have a negative. And so we now just need to simplify, there we go, that's better. So it gives us an I square root of 18. So we now just need to simplify the square root of 18. Square root of 18 is simplified using a prime factorization. What times what gives us 18? Well, there are several different things you can say. So let's just say 3 and 6. Notice that 3 is prime, but the 6 is not prime. So I'm going to go ahead and make that as 3 times 2. Looking at the prime factorizations, we have 3, 3, and 2. They're all prime. So we're done with the prime factorization tree. And we're working with the square root. So I'm going to look for pairs of 3's in this case. So 3 times 3 is 9. And what's not circled is the 2, and that's by itself, so just leave it as 2. So what I'm going to do is make this I times the square root of 9 times 2. And again, just break this up into two separate radicals. That's going to give us I square root of 9 times the square root of 2. But what is the square root of 9? The square root of 9 is just 3. And just like before, we don't like writing the coefficient to the right of the I here. Same thing here. So I'm going to put the I between the 3 and the square root of 2. And that's going to give us 3i square root of 2. And that is the simplified form of the square root of negative 18. Excellent. Let's look at letter G now. With G, we again begin by bringing the negative on the outside, making it an I. And then we simplify the square root of 150. And to do that, let's go ahead and do a prime factorization of 150. What times what gives us 150? And there's a lot of answers to this. So you can go ahead and answer this. The way that I see it easiest is 10 and 15. The reason I say that is because anything that ends in a 0 is divisible by 10. That just makes it easier for me. So 10 times 15. Well, what gives us 10? Well, 2 and 5. And what gives us 15? Well, 5 and 3. Notice 2, 5, 5, 3, they're all prime. Therefore, we're done. And again, we're looking for pairs, and there's a pair of 5's there. Excellent. So 5 times 5 is 25. Times what's not circled is 2 and 3, so 2 times 3 is 6. So you should think of 150 as 25 times 6. This is going to give us I square root of 25 times 6, which means we can break this up into two separate fractions as the square root of 25 times the square root of 6. And again, square root of 25 is just 5, which gives us I times 5 square root of 6. But again, flip these two because we like to put the I right there. So our actual simplified form here is 5i square root of 6. Excellent. Now let's look at letter H. For letter H, we have the square root of negative 13 over 9. I'm going to go ahead and make this the square root of negative 13 over the square root of 9. And then look at these individually. Square root of negative 13 has has a negative underneath the radical, which gives me an I on the outside. And in the denominator, square root of 9, well, 9's already a perfect square. So square root of 9 is 3. And if you notice in the numerator, 13 is actually prime already. There's nothing we can do because there are no perfect squares within that prime. So the answer actually is I square root of 13 all over 3. Alrighty. I believe that's it for this example. I'll see you in the next video. Have fun.